All right, so page 3 of the 1114 notes, 11 through 14 notes. And now we're getting into solutions to an equation. And so this is a little bit more of a conceptual idea. And what does it mean to be a solution to an equation? It means that if you plug the values from your solution into the equation, it'll make the equation true. So actually, let's go and write that out. It means that if you plug the values um, from your solution, you plug those values from your solution into your equation, it will make the equation true. Make the equation true. Um, that's so whenever, like, if you look down below here, we've got some if the following are which of the following are on the graph, and so we're going to take those values and we're going to actually plug them in and see if it ends up being a true equation at that point instead of being false. Um, and so the kind of the follow-up question here right below though is that are all solutions to an equation or system of equations on the graph of the equations? And so in other words, are all the solutions, here's our lines from earlier when we were dealing with perpendicular lines, but if are all the solutions, I'm going to delete that one there, but so here's an equation of y equals negative 3x plus 14. Are all the solutions to this equation on this line? And the answer is yeah, that they are. Um, yeah, depending on how you think of it, either this line um, is made up of all of the different solutions. There's an infinite number of solutions here. Each of the infinite number of points on this line is a solution to this equation. Um, the equation and the line really are the exact same thing, just different representations of the same information. That it might be here in its equation form or it might be over here graphically, but they are the same thing. So yes, every solution to this equation is on this line because they are, again, they're the exact same thing. So yes, a resounding yes, they are. Now, uh, knowing that information, we can kind of approach these next set of questions. Which of the following are on the graph of 2x plus 3y equals 15? And so we've got 4 different points here, and we need to find out, are they in fact solutions? And so to see if they're on the graph, or sorry, we need to find out to see if they're on the graph, and if they're on the graph, again, hopefully from what we just talked about, that we know that they, if they're on the graph, that they are solutions. So what we're going to do here is take our equation of 2x plus 3y equals 15, and we're just going to plug in our different x and y values. So 2x, or 2 times something, plus 3 times something equals 15. And let me take a second just to copy and paste that, because we're going to use this form right here all 4 times. So copy, paste. All right, so we'll use that over here. Maybe this wasn't the fastest way to go about it. And all right, there we go. We've got our 4 equations now. So sorry about that. Now let's plug in our x and y values. So in the first one we have our x value of 3 and our y value of 3. I'm just plugging into right here. And that gives us 6 plus 9 equals 15. And we should have a question mark here because we're still figuring this out. Does 15 equal 15? And the answer is yes. So is this on the graph? Yeah, so it is a solution. All right, number 2, we're plugging in the points of 9 and, oops, 9 and negative 1. So we have 2 times 9, which is 18. We're saying, is this in fact equal? So 18 minus 3, is that equal to 15? And 15 equals 15. So yes, it's a solution. All right, so we've already had 2 solutions for that equation. And here's 2 more. Now we've got to deal with some fractions, and that's all right. Don't be afraid of them. Fractions are real useful to be able to use and to get comfortable with. And actually, while I'm here, let me just go ahead and fill in the next one. 10.5. The next one's going to be decimal, and 12. All right, so there, that one's ready for us. Now, 2/5. Remember, fractions, we'll say this over and over, fractions are just division problems. So if I have something divided by 2 and then I multiply that by 2, those 2's cancel out, and I'm left with 5. And if you thought about it as 2 times 5 is 10, and 10 divided by 2, that's fine as well. You get to 5 either way. So 5 plus, over here, 3 divided by 3 is 1, so plus 10. Is that equal to 15? And yeah, it's equal to 15. So we've got 15 equals 15. Yes, it is a solution. And last one, get some decimals here. So 2 times negative 10/5, that's negative 21, plus 3 times 12, that's 36. Is that equal to 15? And in case you're not sure what this is a question mark sitting on top of our equal sign. We're saying, is it in fact equal? And before we say that it is or isn't, we need to get down to the end. So negative 21 plus 36, that's 15. Does 15 equal 15? Well, of course it is. So yes, it's a solution. All right. Hope that helped. Actually, before we finish up, let's head on real quickly. Just go back to our graph here, and the equation was. And if you're feeling comfortable, you don't need to stick around and watch this, but I think it might be useful. So 2x plus 3y equals 15. So I'm going to change this. Actually, we'll just close this one, delete that line, and we're going to say 2x plus 3y equals 15. And we're going to go ahead and graph that line and get rid of these other points over here. And so we said first off was, no, that's not it, was, there you are, was 3, 3 a solution? And so is 3, 3 on this graph? Yeah, there's 3, 3 right there. Was 9, negative 1 a solution? We said yes, so 9, here's our graph, 9, negative 1. There, that point is also on the graph, just like we thought that it should be. We have 5 halves and 10 thirds. That's 2 1/2 and 3 1/3. Come back over to our equation. That was 5 1/2. Or was it? Sorry. No, 2 1/2. 2 1/2 and 3 1/3. So 2 1/2 right here, and then up 3 1/3, and up. There's that point right there. That's a solution. And lastly, it was negative 10 1/2 and 12. So negative 10 1/2. Got to go all the way over here to negative 10 1/2, and then we're going to head straight up, and it should be right at 12 when it hits, and boom, there it is. Negative 10 1/2, 12. All our solutions were right on the line. If we'd gotten something that was not equal, it would just be off of our line. It wouldn't be a solution. It wouldn't be part of our equation. All right. Hope that helped.